But we can realize this first, second, third entity are the same information. That describe what? Each department. And also, this is the name. And this is the department number. This is the manager name. And this is the start date. So they have the common information. Sometimes you may have the HR has a phone number. The other are not. Okay? But our goal is to find the common information. Why? Computer is not that smart. So if we define, think about the structure, data structure. Data structure is a kind of standardization. We try to standardize the information about each entity. So if we find this entity is the name, number, manager name, and start date. This entity has the same information. This entity is the same information. We can make them group. Okay? Instead of managing separately here and there and here, so this is the grouping information about what? Department. Okay? That's your job. Okay? It looks like the simple here, but in real, the project is not that simple. Sometimes it can be one entity or it can be the many different. But this time, our goal is to find group of entity. They are the same meaning. Okay? Department, department, and another department. Actually, this time, this is called the entity type. Think about this one. One, integer. Two, integer. Or I is integer, J is integer. So by grouping, so this is the integer data type. Okay? So similarly, so this is the entity for HR. This is the entity for the payroll. This is for the admin. So we can define these are the same information about what? By grouping department, entity type. So actually what we identify here is the entity type. Okay? So, one more time. What is an entity? Entity is a real thing. So from the real thing, a lot of things, I try to grouping. Same meaning of thing, same meaning of entity. This one, this one, this one. That is called entity type. So the goal of the modeling, conceptual modeling, the first step is to identify the entity type. Okay, that is the department, employee, project, and the dependent. However, from now on, I'm going to use the entity type. It's the same as the entity. So nobody uses actually entity type in the real life project. If you join the real project, they said how many entities you identify. Well, please give me the list of the entity. At the time, not list of all the entity. Instead, that means entity type. So please, however, you should be able to differentiate what is the entity type, what is the entity. But throughout the semester or even after the semester, in any database design, when we are saying the entity, that means entity type. Okay? So we are going to use the name of the entity to identify. So we can identify the full entity in this example. Any questions? It's very simple, but this is a really simple case. So we need the concept of the ER modeling, conceptual modeling is very simple. But the more important thing is the practice with the real data. And also in your project, you can practice by yourself by creating and more requirements. So this is the first step. I should not end. So second step is the first we identify the entity or entity type. The second step is because we already realized. So we already realized here, each entity has name, number, and the manager, and start date, and so on. There are information, and also they are common information. This is called attribute. So next step, the second step of the ER modeling is we are going to identify the attribute of each entity or entity type. So for example, the first department. Each department has the name, okay, and also number, and employee who manage the department, manager, and we keep track of the start date of the manager, okay, and the locations. How many locations? Several locations. Okay, so to make the space, we can keep the start date here and location. So these are the attributes of what? Department. To clarify that this is the attribute of this one, we are going to use another notation for the attribute, the over, then connect to the associate, the entity type. So for example here, it can be name, this, number, this, manager, this, start date, this, location, this. Okay. Similarly, we can do the project. Each department has controlled the number of projects. Each project has the unique name. So each project has a unique name,
Unique number.
and the number,
Single location.
and then
Single.
location. And just like the previous one, we can use the diagram. Okay? Very simple. And next, the employee, we have the social security number and the address. For the address, I'd like to use that here. And the SSN and salary, sex, and the birthday, DOB. And similarly, we can use this. Why don't you do the department by yourself? Dependent. Yes. The question is the employee name. Employee name is mentioned here. Then right now we don't have to. Okay? Which means they do not keep the employee name.
Because employer ID is also not there.
Yeah, there is no employee ID. Okay? So this is a conceptual. I know most of you are familiar with to use the ID. Okay, well, I will explain why we need such an ID. Sometimes intuitively we add something, the student ID, employee ID, something ID, transaction ID. I will explain the later, probably middle of semester. That makes sense also, because in considering the performance. Okay? But this time, just follow. This is not the computer science class. It's just a conceptual level design for any student. Even this can be done by the high school student or the middle school. The student can do that. Just following the description. So, for example, dependent. Each employee may have a number of dependents. Keep track of their name. Okay, and sex, and DOB, and the relationship. then we can create okay, these are the attributes that we are going to we identify. Okay, sometimes we can understand attribute as the column. If you are familiar with the table style, the definition, like the Excel file, Microsoft Excel file, row and column, sometimes we can understand regard the attribute as a column. It's informal, the terminology. So database management system uses the column instead of the attribute. Okay, same meaning. So then next one is in the handout, the next step is a relationship type, but instead we are going to take a look at more details of the attribute. There are different types of attribute. Just like the name, number is the normal attribute. Normal attribute is just the attribute. Another one is, if you take a look at the location, so if you see our requirement, the last part of the first bullet, a department may have the several locations, but the project located at a single location is very important in relational database model. It's not very critical, most of the database model, but except the relational database model. We will see why later. But right now, we are going to identify multiple value or single value. So especially the multiple value, multi-valued the attribute. So we will use double over, like the location. Okay, but this one is a single value. What about the other? Name, how many names for the department? 1. And how many number? 1. How many manager? It's a single, a manager. And the name, all the others are single value. But this one clearly mentioned several locations. Later, we will see why we identify the multi-valued one. So in the project, you also need to identify the multi-value. The answer is relational database cannot take care of multi-value. Why? What is different to single value, multi-value? If we allow the multi-value, like the object, we need to consider a number. We don't know whether it's, this value has the single or the many. We need to always check. It's overhead. So it will be slow in terms of performance. So because of that, relational model allow only single value. Then it will be simple to access. Always when I find the seat, it's only single value. There are not, this is not owned by the many students. If many, I need to identify again and again. So that is the reason we are going to identify the multi-value. One more thing is the composite. So composite attribute is, for example, address. Sometimes it's not mentioned here, but if we specify the address, like the street number, street name, and the city name, and the state name, and zip code. Sometimes we can specify the address, okay? Specific address. Another example of this one is the name. Name can be first name, middle name initial, last name. In this case, if you can specify, okay, or if the one attribute consists of the number of the component, we can use such another level of the attribute. Okay, it's like the tree structure. Okay, in each case we can use such a composite attribute. If the customer specify the we keep track of street number and the street name, city name, and the state name and the zip code for address. Then at the time, instead of creating the new entity, we do better to use such a composite attribute. Okay, it depends on. So, but in our case, which is not, but in case that is specified, we can use such a composite attribute. Okay, so there are different types of the attribute. One more thing is I'm going to add one more step. That is actually the identify the key attribute. So key attribute means, what is a key? Key to access, key to find. So if we go back to here, this is an entity, another entity, another entity. If we can identify the specific entity using attribute, for example, in this case, this is the department using number. We can identify the specific entity. Okay, at the time, this attribute is called key attribute. What about the name, department name? In this case, yes, nobody wants to create the same name of department in the same organization. Okay, like the computer science department and another computer science department. Actually, that is true in the university. Some of the university has the computer science in art and science, computer science in engineering school, even computer science in business school. So, but the most of case in this company, they will not create the same name of duplicate name of. So we can use the name as the key. So that is a key attribute. So in that case, if you can identify such a key attribute, we can use the underline. For example, department name is key. And the number is a key attribute. So how many key attributes? This department has the 2. What about the manager? Sometimes one person can manage the many. So we are not sure at this time. It's not clear. At that time, you don't have to. The Saturday is the same thing. What about the employee? SSN, definitely. SSN is a social security number. It's not actually identification number. It's a user for the social security benefit in US. Okay, if you pay the tax, then for example, it's after retirement, there's no income. Or I got the problem by the spouse, passed away, so no income. Then at the time, social security is kind of a social net to protect the poor or some disability or the worst case. At that time, we can use it. But such a benefit should be identified. Because of that, social security number is unique for all the person. I heard that the controversial, actually social security number is not really unique, but we consider the social security number as a unique number. It's a 10-digit number. So we can use the social security number here. Salary, we are not sure. Sex and the DOB, definitely not. Address, also definitely not. So in this case, we can use a social security number. Okay, then what about the project? Project number is clearly mentioned unique number. And the name also clearly mentioned. It's very nice, it's a unique. So then, dependent? Name. So, you have a son named Nicholas. I have son, the Nicholas. Maybe complete. right? So we cannot use at this time. Instead, partially, we can use, okay, partially. It's your Nicholas and my Nicholas. Partially, we can use the name as a key. It's not the really key, but partially we can, at that time, it's the dot line. We can. It's kind of candidate later if we combine with the employee, but this is not a key, but it's called a partial key. So as you can see, sometimes how many key? 0. We do not have a key. Sometimes 1, sometimes 2, sometimes 3. In conceptual design, it doesn't matter how many keys. I know if you know the database allows only 1 key, which is called the primary key. Later we will see. That is the database design. This is not the database design. This is a conceptual level design. Okay? So it may have the key or sometimes not key. Basically, if the entity does not have the key, that is called the weak entity. So weak entity, no key. Like this one. It might be possible. Because it's just conceptual. It's not database system. It's not computer system. Okay? But if the entity has the key, which is called a strong entity, but just an entity. Okay? We prefer, as a computer science, such a strong entity, right? If we do not have the key, it's very hard to search. It should be brute force way. Okay? But if we have a key, unique, the value, it's very easy to search the data. Think about the remind. What is the main goal of using database? My definition, search data very fast. That's our goal. If we have a key, unique data, it's very fast. If not, it's always brute force way. Okay, brute force means linear search. Search all the data. Okay? So that is O over N. If we have the more data, it takes a longer time. So this is the second step about the attribute. So up to including key attribute. Okay, so that is the second step. That is pretty much the half of the entity part. It's very simple. However, in the real life system, it's not that simple. So for example, when I joined the first project as a database administrator, so my project manager invite his room. Then when I enter his room, it's I think even smaller than my office, but all 3 sides of his room covered by the ER diagram. Then the ER diagram includes more than 2,000 entities. It's just almost a dot. And print out all of them. Every day is change it. So he said there's more than 2,000. To identify the 2,000, it cannot be done at once. It takes usually several months, really. And keep revising whether this can be combined or this can be separate. Whether this is the attribute, this is the entity, whether this is the later we will see the super and subclass and so on. So, but this is just for your practice, and then is the obvious case. Okay? So that is the identified entity. However, if you know the data itself very well, it's not very difficult. So always such a conceptual design works with if you embark the project, such a customer or their employee. Okay, because they know much better. Okay, some of them are not documented. Many of them undocumented, but should be implemented. So at that time, you need to discuss a lot and work together. Okay, so this is the entity and their attribute. However, if you take a look at the description, like the company is organized in the department and blah, blah, blah. Employee who manage the department. So, in other words, I brought many. So Lee manage HR. So I found this information from the description of the file given by customer. And James manage the payroll. And the Peter manage IT. And so on. So you realize that I think we'd better put the name. Name used a lot. Let me add the name for our company. Its name is not here. I don't know why the name is not here. Okay, let's say that there's a name. So like this one. So, because eventually we need the manager, the name. So, if you see this one, so you find this kind of information from the given, the description by the customer. Then, this is what? This is employee. And this is the department. So it's already entity we identified. This is another entity we already identified. Entity type, entity manage the department. Lee managed HR. James managed the payroll. The partner managed the IT. So it's not like such an entity. Instead, this is the entity, something entity. So this is called the relationship. We can identify first entity, but after we identify the entity type, we can find some relationship between two entities. So this is called the relationship. So one relationship, another relationship, another relationship. Just like the entity and entity type, by grouping same type of the relationship. Employee manage department. Employee manage department. It's the same the type. So this is called the relationship type. What is the name? Manage. Okay? But just like this one, instead of the relationship and relationship type, interchangeably we can use a relationship instead of the relationship type. So for example, if we take a look at the first bullet, employee who manage the department. We keep such a manager information here, but actually this manager is part of the employee. It's the entity. So it's something duplicated. Instead, we can identify the relationship type. So that is the manage relationship type. Okay? To represent such a relationship type, we are going to use this diamond symbol. Okay? So for example, this one, manage. Then connect corresponding. This. Manage. Okay? Then we don't need this because it's a minus. Okay? Then if we want to find the manager information, we can connect. So we can go through the manage and go into the employee. This manager Lee is in the definitely employee. Okay? So this is called the relationship. So any other relationship? If you are smart, you already realize I already used the italic. Yes.
Can we do relationships between attributes, or we always do like between entities?
His question is that when we identify the relationship, is it between the attribute or is it between the entity? It's always
So we don't do
entity.
it between attributes, right?
It's between.
So we don't do it, we can do it between attributes. It has to be always
So can we make what is that relationship?
Because
Start date and this one. Start date is a part of the entity. So we can say the relationship is the relationship between entities. Okay. So we can identify the first manage. Any other? The second bullet, each department controls the each department control the number of projects. So, for example, the department 1 control project 1. Department 1 control project 2. Because the number of, okay? Then, by combining all of this, department control the project. So, we can identify the relationship. So, we can create relationship, control, and connect to correspond. Okay. What else?
If I have dependent.
We store the each employee, blah blah. Each employee. The first, the sub-block of the third, the block. Each employee works for one department, right? The each employee works for department. So works for department. Enter this. Then we keep track of the number of hours per employees currently works on each department, which means employee works on each department.
not dependent. You wrote for dependent. Department. You joined for dependent.
Oh, it's a dependent. Oh, sorry. Something weird. So it's a department. This one. I need to have the more space, but you can understand. Okay? So this one is between department and employee. There is another one works on each employee works on project. So works on project. Works on project. And each employee have a number of dependent. So has. Dependent. Okay, so we can identify the number of the relationship. There's another one. The project control, department control. Oh yes, so we already did. Okay, it looks like a simple because in the description, actually the mention very clear, 99%. But in the real life project, the example, it's not that simple. Some of them, it looks like many times it's a vague. Okay? At that time, you need to first analyze the data